For the last part of section 5.3, we are going to be looking at special products and rules that will help us work faster through solving quadratic equations by factoring. So to start off with, we have two vocab words here, binomial and trinomial. A binomial is a quadratic expression that has two terms, so two chunks. And a trinomial is also a quadratic expression, but it has three terms. So, in the chart here, I have the two different shortcuts that we can use. The first one is called the difference of two squares, and that is where we only have two terms, so it's a binomial. It has to be a binomial, and you can take the square root and get a whole number of both the first term and the last term. And then it has to be subtraction. So perfect squares for the first and last term, and it has to be a subtraction problem. If those two things are true, then we can factor it quickly by making two sets of parentheses, one with the perfect square number plus the last perfect square number. So for example, let's say we had 49 minus 36. No variables included here. The square root of 49 would be 7. So 7 times 7 is 49, and 36 would be 6 times 6. So my answer then would be A is 7 and B is 6. And then A is 7 and this one is minus the 6. So we would write it like that. So if they're perfect square trinomials, two sets of parentheses, one with an addition, one with a subtraction, and whatever the square root of each one goes in the first and then the last set in the parenthesis there. And then over here, the perfect square trinomial is where we have the first term is a perfect square. So that value there you can take the square root of. And the last term is a perfect square, so you can take the square root of that number as well. Now, as you notice here, you can have a subtraction or you can have an addition. And the last one has to be addition. But depending on the first, right here, if that's a subtraction, then our answer is going to be subtraction. If it's addition, then our answer would be addition. So the way you check these to make sure that they work is you take the square root of the front number and the square root of the back number, and then in the middle you do 2 times, it's always 2, one of the front, so an A, and one of the back, which is a B. And then that number should match up with what you have as your problem. So I know that kind of doesn't make sense right now, but when I do the example, I'll show you what I mean. So for my first example, we have 9x squared minus, equals 1. We want it to equal 0. So I'm going to solve for 0, so I'm going to minus 1. I can't do 9x squared minus 1, so I'm just going to write 9x squared minus 1, and 1 minus 1 is 0. I can take the square root of 9x squared, and when I do that, I get 3x. The square root of 9 is 3, and the square root of x squared is x. I can also take the square root of 1. 1 is 1 times 1. So if you look up here, it says that if it's a difference of two squares, which it is, we have a subtraction here, that we can write our answer 1 from the front plus 1 from the back, and then 1 from the front minus 1 from the last number. And then that is our, oops, it's not our final answer. Getting too far ahead of myself here. Then we have to figure out the zeros of each thing here. So what could I plug in to make each one of these 0? So I'm going to subtract 1 from both sides. And I have 3x equals negative 1. And then I'm going to divide by 3 on both sides. So I'm going to have x equals negative 1/3. And then I have to do the same thing for the other set of parentheses. I'm going to add 1 to both sides to start off with. And then I have to divide by 3. So x equals 1/3. So my zeros of this quadratic function is negative 1/3 and positive 1/3. And then this one, if I want it to equal 0, I have to minus this 40x. So that would be 0. I'm going to write these in order. I have an 8x squared, then our negative 40x, and then a positive 50. So I notice that all three numbers are even, so I'm going to divide them all by a 2. So I write that 2 out front. Now I'm just going to be focused on what's inside the parentheses there. So I notice it has 3 terms. I also notice that I can take the square root of 4x squared. Square root of 4 is 2. Square root of x squared is x. So, and then the last term, square root of 25 would be 5. And then just to check to make sure this works, 2 times 1 from the front and 1 from the back should give us that 20x. So 2 times 2 is 4x times 5. 4x times 5 is 20x. So yes, this works. And notice it is a subtraction problem here. So we're going to go back up to that chart. And the first one here is the subtraction. So we're going to have a minus b squared as our answer. So a is the first, so that's a 2x, minus b is the second, 5 squared. So what that means is that we have 2 of them. This is just a simplified version of this. So instead of writing it out twice, we can just say squared. And then we want to find the 0. Where does it cross the x-axis at? Oops, I don't want a parenthesis. I want equals 0. So we're going to add 5. So I have 2x equals 5, and then I have to divide by 2. So 5 divided by 2 is also 2 1/2. So this one has 1 0. It crosses the x-axis at 2 1/2. Now, if that would have been a plus sign in front of that 20x over here, if that would have been plus, then this would have been a plus here, and then my answer would have come out as a negative. But that's the only difference between those two in the chart above. All right, example 5, our last example, it says write a quadratic function in standard form with the zeros 2 and negative 1. So now they're telling you what the zeros are, and they want you to work backwards. So we know that in order to have 2 as a 0, I have to do something to that to get 0. So I would have had to do x minus 2. I would have had to plug 2 in that to make 0. So that's why that answer would be 2. And then to get an answer of negative 1, I would have had to have had a plus 1, because I would have to plug in a negative 1 there to make that 0. So equals 0. So that's our factored version, but they want it in standard form. So now what I have to do is I have to FOIL. So first, I have to review FOIL here. So FOIL is first, outside, inside, last. So we're going to multiply the 2 first terms. So x times x is x squared. Outside would be our 2 most outside, x times 1. So that would be a 1x. Inside would be negative 2 times x. And so that would be a negative 2x. And then the last 2 terms from both sets would be negative 2 times a positive 1. So that would be a negative 2, and this all equals 0. Then you have to combine like terms. So x squared is by itself, and we have a positive x and a negative 2x. So that would leave us with a negative 1x, so minus x minus 2 equals 0. So that would be my standard form, that ax squared plus bx plus c form of the quadratic function with the zeros 2 and negative 1.